on this homework assignment. This is a 1.6 that we had for today. Here's kind of like a fair warning. We're going to have a chance to think about this more tomorrow. So even if you're having trouble right after this homework or watching this homework video, and thank you for watching, know you're going to have a chance to work on this a little bit more tomorrow. But hey, let's just jump into it. Let's do some integer work. Now, this goes back to what we were saying in class before about the automaticity of working with these integers. So this whole homework assignment is kind of designed as a review to help you become more automatic when dealing with integers, particularly those which are negative, especially when adding and subtracting. So we're asked to take each of these subtraction problems and turn them into addition problem. So to do that, we have to look at these in very kind of unique ways. And some of this might be a little strange. Maybe you've never been asked to think about integers, especially subtraction, in the way you might see here in the next few minutes. But I'm just asking keep an open mind and know that you can always go back, double check these answers, say with like a calculator, and determine if what we wrote actually does work. Alright, so let's take a look at number one. To handle number one and turn that into an addition problem, we have to kind of look at these two elements as separately. So what I mean is, look at this negative 2 as one item, and then look at this negative 3 as a whole other item that we're just trying to combine together. So if we kind of keep that negative with a number, we can rewrite this as a negative 2, and then separately as a negative 3. And then combining, of course, now kind of implies addition. So instead of writing as negative 2 minus 3, we can say, well, we have negative 2s, and I want to add 3 more negatives. In the end, the answer is still negative 5. Again, double check the calculators. Don't take me at my word. Let's take a look at B. So B, we start with an 8, and then we have to kind of combine it with this negative 1. But notice we have two negative signs in a row. So there's lots of different ways you can think about this. But here's the way I'm gonna encourage you to think about it. We start off with this 1, this value of 1. Okay? And the negative kind of implies that I now need the opposite of 1. We talked about opposite numbers today. So we have a 1, opposite 1 is negative 1. Well, we need to take the opposite again. So if you kind of think about a number line in this sense, if we start with a 1, this first negative right here means we need to take the opposite value of that. So we'll hop all the way over here and go to a negative 1. And so this guy right here means we got to hop back. We need the opposite of that. So the opposites make us jump the number line one direction or the other. So in the end, what we're really looking at here is 8 plus 1. You might have heard a rule like 2 negatives make a positive. Like this is a version of what that rule means. It means taking the opposite twice. C is going to be very much like A. So we take these elements separately. We have a negative 4 and we have a negative 9 separately. So we can combine them through addition. So again, we start with a negative 4. Then we're going to add 9 more negatives. This one is much like B. We have these two negative signs. So we'll have a negative 1 plus a 2. And this is going to be like A and C, where we have this negative 6 to start with, and then we're going to add 2 more negatives. Okay? So notice the way I was saying that. I was saying kind of in a weird way, but that's a way you can definitely mimic if you want to get a better sense of what these integers are asking you to do. Whoop. Okay, so problem 2, we have to model each of these using algebra tiles. Guys, I don't think we're going to do that. Let's just forget about that momentarily. And crossing off 0 pairs if they exist, and we'll report a final answer. What we're going to do is really